Hey, seventh grade. We're here. Did that red line follow program, and hopefully you saw how your robot performed there, because that's going to be an important informer for this particular challenge. Specifically, well, we'll look more specifically in a few seconds. So challenge 8 is another line to sense. So we're going to use that color differentiation sensor again to help guide our robot through a path. There's a strong chance you should be able to use the program that you wrote for this for that red line follow and tweak it just a little bit to make it work for this next program. So let's take a look at requirements expectations. You're going to see they're very similar to that red line follow. Right. So again, we're looking at the basic concept is the robot must follow a white line now. So instead of a red line, we're following a white line. Following the requirements, must use the sensor to direct its motion. Same. Must be able to follow the line or the edge of the line. Again, that's the same. And robot must travel from one end of the path to the other. That's the same. Diagrams, we're going to see a lot of different diagrams, right? All those diagrams are paths that we've either seen before or that are out there for us to see in the world of pathedness, I suppose. We'll talk more about what I'll probably use, but that's where we're going. Additional information in the color sensor, white can be selected as a color for comparison. So last time we selected red as the color for comparison. We can also select white as the color for comparison, and that's not difficult. Paths are white on a brown background. If that sounds familiar, it's because it should be. All the paths that we looked at before that red line follow were white paths on a brown background. You're going to see some of those possibilities coming up. Reflected light intensity measured on the white lines is 40 and above. Reflected light intensity on the brown board is below 20. So if you're using reflected light intensity setting on the sensor rather than the compare color setting, then that's what you're looking for setting up your settings. Again, we'll talk a little bit more about that when we get to the program. So here's the thing. I'm just randomly going to pick one of the paths that we've looked at before as the path for this program, right? And this is the thing that I would emphasize to you. This is maybe the worst of the paths, right? And that was the one we used, gripper path 2. But gripper path 1 is likely the one that we'll end up using. But here's the thing I want to emphasize to you. Even though this path has as few 90-degree angles as any of the other paths, right? Fewer, 90-degree angles than any of the other paths except for this one here, which is only one 90-degree angle. Same here, only 190. The 90-degree angles still will be the issue that you must make sure that your robot deals with, right? So when we watch those red line follow programs, the thing that we should have noticed was that 40-degree turn where we're turning just clearly wasn't quite enough to catch that 90-degree angle perfectly, right? So when we turned around that 90-degree angle, sometimes we missed it, had to cycle around before we caught that line again. So the biggest thing I would encourage you to think about when you're writing this program is, how can I change my red line follow program just a little bit to make it so that it's turning more discreetly so that it can catch that line or can stay on the edge of that line as it follows around the path. So even if we're looking at this path and then we've only got the 190-degree angle, keep in mind, I'm going to start that robot anywhere on any of this path. So it could have to go all around all of these 90-degree angles on the actual start box, right? Because it's not going to go in the start box. It's going to go on the outside of the start box and have to follow that line as it continues around the outside of the box. So outside of the box, 90, 90, and then that inside 90, right? So this outside 90, outside 90, and then inside 90. Still got to deal with 90-degree angles. Even if you only have one, there's still 90-degree angles on getting yourself from that start box to the actual path as well. So again, 90-degree angle is still going to be the biggest thing that you need to deal with. Enough yakety yak. Let's get to the programming. So if we go to our Mindstorms program, again, the last program that we wrote worked pretty well for this, but there are tweaks necessary. In the last program, we had a loop set up, right? An infinite loop or an unlimited loop is what they call what Lego calls it. And inside of that unlimited loop, we put a switch, what Lego calls a switch, and what I would continue to emphasize to you is probably more accurately called a an if then else statement, right? An if then else statement would be what most programming circles would call that statement, right? We're checking this. If something's true, we're going to do this. If it's not true, else we're going to do this, right? Again, we're going to need to set up not the touch sensor, but rather the color sensor. And again, I'm going to set it up to compare specifically color. I will have to change the sensor this time away from red. So I'm going to deselect red and select white because I want to look for that white line in order to follow it. Again, lots of different options here. In this case, I'm going to tell you I would recommend you use a move tank, right? And set that up. Well, it comes in for you as 50-50. Keep in mind, this is the other thing that we talked a little bit about. I guess I shouldn't have zoomed out at all earlier. When your switch, you won't see both paths in your switch. So the easiest thing to do to communicate to me what your program is just to put whatever you would put in that X path. Just put it underneath your the rest of your code so that I can see what's supposed to be in that X path. That way, I'll know what your program is, and I'll be able to get that program into onto the robot. So again, when we set up that robot to follow the red line, we made one of those motors at 50 and the other one at 0. And then we did the opposite when we didn't see the white line or the red line. On for degrees makes a ton of sense, right? We want smaller turns, and then we used 40 degrees there. On for degrees, and again 40 degrees. I would tell you for this, to deal with the 90-degree angles, I would encourage you to think about two things. Specifically, I would actually go with even smaller rotation. So maybe 30 degrees instead of 40. A smaller amount of rotation is going to give me tighter turns, hopefully, right? The other thing I would encourage you to do is to note that while I've got 50 degrees here, I can actually make this robot turn more sharply by going to a negative power value on the other motor. So if I went -10 here on the other motor, that would make my robot turn more sharply. So I've got 50 on my in this case the left power, and the right power is going to be -10. So it's actually going to back up that wheel a little bit. Same thing here. I'm going to make left power -10 and then right power 50. This has got a good chance of making sure that I'm turning more tightly as I continue down that path. And hopefully, if I'm turning tightly enough, I'll be able to follow the edge of that line, even if we're dealing with 90-degree angles. I would encourage you, those of you that have kind of developed your own signature blocks, I would encourage you to add that. For me, you guys that know that signature block is Lego Sound, Animal, Elephant Call, the thing of beauty. Even though we'd never get to this because we're never going to leave this unlimited loop, it's fun in my mind to see your guys' signature code blocks on your program. So again, to show me what your program is in that X branch, just put it underneath your loop, and then feel free to make sure that you include your signature blocks in your code as well. That's about it for this program. I think that should probably do it. And I'm excited to see the programs you guys write. And again, let me know, get in touch with me via email if you got any questions or anything like that. That's it, guys. Let's get it done.